We are going to talk about co-function trigonometric identities. So again, co-function trig identities in this video. Pretty much if you have trouble filling in the activity guide, this video is going to help you to do so. And in your activity guide, we're trying to find how sine and cosine relate. We try to find equations which have sine and cosine in them, and if we substitute any angle, those equations will be true for any angle. That's what the word identity means, right? So let's jump to the example from the activity guide. You're given a triangle. It's a right triangle. We're dealing with trigonometry, so we always talk about right triangles. And in this right triangle, you have, let's name it, it was N, M, and R. You have a right angle here, and you have an angle called X. So the first question you have to answer, I'm going to split my page in 3 parts, because there's 3 questions that you have to answer in your activity guide. I really don't like how straight this is. There's 3 questions you have to answer. So the first question was, find the value of R in terms of X. Okay, so what is the value of angle R in terms of X? I can't find a number for R. I cannot find a number. I can't say R is 45 degrees. Or R is 60 degrees. I can't do that because I really don't know how much N is. However, if I know that angle N is equal to X, I can write an expression for angle R. Here's my expression. I know that all 3 angles, angle N plus angle M plus angle R, are equal to 180 because they are the angles in a triangle, and all angles inside a triangle add up to 180. Instead of an N, I'm going to write X. Instead of M, I'm going to write 90. And R, I'm just going to leave R equals 180. Now, I want to solve this equation. This is pretty much an equation. It has 2 unknowns, but I'm just going to ignore X. X to me is as if any other number, okay? I have to solve it for R. So my real variable here, real unknown, is R. So I want to leave R by itself. So what I'm going to do is I'm going to transfer X and 90 to the other side. So I'm subtracting X and I'm subtracting 90. And if I subtract it on this side, I got to subtract them on this side. Minus X minus 90. What do I get? Here these cancel out. I get angle R is equal to 180 minus X minus 90. Well, therefore, angle R is equal to 180 minus 90 is just 90 degrees minus X. So this is the answer to the first question. R expressed in terms of X is equal to 90 minus X. The second question that you have to answer is find out the sine value for angle N and the cosine value for angle N. So sine of, let's first start with the fact that N is equal to X, right? Angle N is equal to X. So I want to find sine of X, and then I want to find cosine of X. Well, sine of X is the opposite side divided by the hypotenuse. So the opposite side is called Rm, right? This side over here, Rm. And the hypotenuse is Rn over Rn. The cosine is the adjacent leg. This is the adjacent one to angle N. Angle N, this is the adjacent one. And the adjacent one is Mn, and the hypotenuse again Rn. Now, let's answer the third question. We want to know the sine and cosine of angle R. We just found out that angle R is 90 degrees minus x. So sine of 90 minus x is equal to, the opposite side from R is over here mn. mn, and the hypotenuse again is Rn. And the cosine of 90 minus x is, the cosine is the adjacent side to angle R, which is this side over here. We call this Rm over, again, Rn, the hypotenuse. Well, guess what? If you really look closely, you will notice that this over here, its right side is equal to the right side over here. Rm times over Rn, and I have Rm over Rn. So here's the big conclusion. Sine of x. By the way, whether I use parentheses or no, it doesn't really matter. You know, you can use them or not use them. It's both are fine. When you're writing more things like 90 minus x, then you have to use the parentheses. However, if you just have one variable as input to your function, you can just put them or ignore them. So I can just put them here if you want. Okay? Now, this is a new cofunction trig identity. What does that mean? No matter what number I put in for x, both sides will be equal. So for example, if I do sine of 0, will it be equal to cosine of 90 minus 0? Well, let's see. Sine of 0 is equal to 0, and cosine of 90 is equal to 0. Yes, this here is an identity. No matter what I substitute in for x, both sides will always be equal. You can also notice another identity, and this is this one over here. Mn over Rn is the same as Mn over Rn. Therefore, cosine of x is equal to sine of 90 minus x. Same thing. Let's substitute this time with 1. Cosine of 1, let's say if it's going to be equal to, it's not 1, I meant 90 degrees. Let's see if cosine of 90 will be equal to sine of 90 minus 90. So cosine of 90 degrees is really equal to 0. And sine of 0 degrees is again equal to 0. Also, yes, this over here represents a cofunction trig identity. Therefore, no matter what number I put in for x, both sides will always be equal. Hope this is clear. Let me know if it's really troublesome to understand it.